Everyone, welcome back to my channel. So today we're going through PSLE 2024 question number 36. So question number 36, the graph shows how a length of a wire made of material S changes with the temperature. So you have temperature, then you have length in mm. So you have this graph over here from 0 all the way to 80 and 50 up to 56. State the length of the wire at 0 degree. So at 0 degree, this is the length. Over here, this is the length. So it should be 50. Don't forget the unit mm. Okay, this part quite important. Don't forget the unit. Okay, without units, marks will be deducted. So state the increase in length. So this is the key. Increase in length. How much it has increased? Okay, not the total length. Okay, so increase in the length of the wire when it's heated from 0 to 80. So 0 to 80, the increase is from 50 to 56. 56. Okay, 50 to 56. So you should be calculating from 56 minus 50, so you get 6. So 6 is the correct answer. So it should be 6 mm. So some of you that never read, okay, you will straight away write this 56 mm wrong. 56 mm wrong. Okay, 56 is the total length. 56 is not increase. 6 mm is the increase. Okay, so read this part very carefully. This is a very easy 1 mark question to get. So if you misread this part, it will be very wasteful. Okay, so 56 is wrong. Okay, so Fadil built a model of telephone line as shown. So you have the sun during the day, and you have the wires made of material S that's pulled tightly. The screw held wire securely to the wooden support, and you have the wooden poles placed in the ground together with the wooden support at the side that is securing the wire. So during the night, he heard a crack and found that the wire snapped. Wire snap means it broke into half. Okay, so there is no wind, and the model was not disturbed by any person or animal. So they purposely put this line because they probably realize that some of them they might say that at night there is animal come and bite the wire, that's why the wire snaps. So you cannot give this kind of reason anymore, and these are non-scientific reason. Okay, so in this case, explain why the wire snap at night. So the key is the wire snap at night. Why not in the day? Okay, in the day and in the night, what is the differences? So you take a look. Actually, the earlier question give you some form of idea already. When the temperature increases, the length of the wire increases. So it tells you that it gain heat and expand. So it probably tell you that the nature of this question got to do something with expansion and contraction. Okay, so you take a look at this. During the day, there's a lot of heat, so the wire will gain heat, expand. Then during the night, what will happen? During the night, the wire will lose heat to the surrounding, and they will start to contract. Okay, the length will become smaller, and they will eventually snap if there is not enough allowance. So let me put it this way. Okay, so let me assume this is the original length of the wire. Okay, let me draw a little bit bigger. Original length of the wire during the day. During the day. During the day. And this is the wire that is found in the night. So in the wire, the length of the wire in the night will become shorter, right? But because of the design of this setup, right, it's secured to the ends. So the wire, in this case, it will become something like this. Okay, wait first. Okay, it will become something like this. Okay, it's being secured to this part, right? Okay, maybe I put this part secured to this part. So the wire will become shorter. The wire becomes shorter because it loses heat and contract. So the blue color wire represents a shorter wire, but at the same time it is still being pulled by the two ends. So there's actually a force acting on the wire by the two sides. Okay, so it will be this. Okay, being pulled by the screw over there and being pulled by the screw over there. Okay, during the day it's not so worse because the length is longer. But during the night is the pulling force is much stronger because the length of the wire is now shorter. Of the shorter length, right, and there's a force that is pulled by two sides, right, it caused the wire to snap in the middle. Okay, it's like a tug of war. Okay, there's a person on the two ends pulling the rope. Okay, pulling the rope. Okay, so eventually if the rope is not strong enough, the rope might snap in the middle. Okay, so this is what it means. Okay, so let me show you on this part. This part is a bit hard to answer because this question is quite novel. Okay, when the temperature was higher in the day, the wires were pulled tightly. Okay, so this is the clue, right? Pulled tightly. Okay, pulled tightly. At night, the temperature decreases and the wire lose heat to the surrounding, causing them to contract and pull even tighter. Okay, which is on this part. The pulling force is stronger. So since the wire were already tightly stretched with no space, room, or allowance for contraction, they snapped. Okay, in the publisher answer, they use the word allowance, but I felt that you can also use space and room. No space, no room for contraction. That's why they snapped. Maybe these two words are much more easier for you to understand. So this part you can kind of use it. Okay, so the main idea for this question is this part. At night, temperature decreases, wire lose heat to surrounding, causing them to contract. So when they contract, they pull even tighter. So there is no room for contraction, they snap. This is the end result. Okay, so in order for the wire not to snap, of course you have to make sure that maybe this part you don't pull that tight during the day, right? You make it loose. Okay, so using the same type of wire and equipment, that means you cannot add something new. Okay, in this case, suggest how Fadil can build a model at the same place so that the wire will not snap at night. Okay, you make the wire looser so that even at night when they lose heat and contract, right, they have enough space, enough room for contraction. Okay, so you can put it this way: build the model with the wire hanging loosely. Okay, this will be the key idea, hanging loosely. Or you can say when fixing the wire to the wooden support, allow them to hang more loosely. Okay, so in this case, it should look something like this. Okay, so the reason is so that there's extra space for contraction to occur without the wire snapping. So in the actual case, let me show it to you. Okay, if I were to draw them, this is the wooden support. Maybe this is the wooden support. Okay, that means you put the wire this way. You put the wire this way. So even at night when they contract, right, they become smaller, right? They will more or less become like that. And the blue color is at night. Okay, so they will still not snap, okay, even though there is a pulling force acting on the two ends. Okay, it will be like the one in the blue color. This is at night. Then this is during the day. Okay, so this should be how it looks like, okay, for part D. Okay, to further add on, some of you may have think of this answer. Shift the wooden pole nearer to each other. Okay, so when you shift the wooden pole nearer to each other, right, then it will appear as something like this, right, over here. But actually, this answer cannot be accepted because the wooden pole, they are placed in the ground. So they are kind of fixed already in place. So this part is actually quite restrictive. Okay, if you take a look at this text over here. So this one cannot be accepted, and they already give you some clue in the diagram. Can you see these are some extra wires? Okay, so it's actually what you can use to use in for part D, which is use the extra wires at the end of the wooden support, right? Create some slack over there that looks like this, so that your wire will not snap at night. So this is some additional part for this question. So okay, let me just zoom out so that you can have a clearer view. Okay, so these are the answers for question number 36. Thank you very much.